Hello everyone, so I think we can start. Let me share my screen. So, am I audible? Let me take the pen. Okay, so good evening everyone. So myself Suvankar from ISC Bangalore. So I am the one of TA of this course. So now we are discussing about the analytical chemistry, some NPTEL online course. The professor of this course is Devasis Ray from IIT KGP. So from last 8 weeks we have learned different techniques about analytical chemistry. So and we also discuss what is the importance of analytical chemistry. Then along with this we have discussed about different type of spectroscopic method, like UV visual spectroscopy, absorbance spectroscopy, and FTIR. Then along with this, how we can use this analytical chemistry to separate the sample, and how we can get to know the electronic as well as functional property of some chemicals. If you get some ore sample from somewhere and you want to analyze that things, so all these things we have learned. Now we will discuss a little bit more details about the electrochemical method. So basically when we will discuss some question before different topics, so that time we there is some option that what is we can measure this thing with an electrochemical method or not. So that things now we will discuss that electrochemical method. So basically on electrochemical method, in this week we will discuss basically some introduction part, so that we get to know some idea about the electrochemistry. Then we will discuss more details about different technique of electrochemistry. So basically cyclic voltammetry or square wave voltammetry or differential pulse voltammogram. So all these things we'll discuss step by step. So before that we'll discuss little bit more introduction part today. So basically electrochemistry or electrochemical method. So what is this basically? I think we already discussed basically before this first class maybe. So basically electrochemistry or electroanalytical method, electrochemistry. So basically what is happening, electrochemistry means electron transfer is there, and chemistry means some chemical reaction is going. So due to the electron transfer something is happening, or some chemical, due to the electron transfer some chemical reaction is happening. Chemical reaction is happening, so that things will means we'll discuss on electrochemistry. So when electron transfer we are telling, that means there is some gain of electron or loss of electron. Okay, so gain of electron or loss of electron. So if the gaining the electron, that process is called reduction. If loss of electron, that called oxidation. So in reduction or oxidation also, if you see in organic chemistry, then we used to say that if the oxygen is attaching, then that is called, number of oxygen is increasing, then that is called oxidation. If hydrogen is attaching, that is called reduction. So that things is there, but we will discuss more about the inorganic or physical chemistry point of view, where we'll discuss on electron transfer process only. Okay, so these things is there, and if electron transfer is happening, so what we can get from the electrochemistry, or where the electron transfer is happening. So you can see that from all the place where the oxidation or reduction is happening, from what is called metallurgical process, or some industrial process, to biological system also in our body biological system, also some electron transfer, or what you can say oxidation or reduction is happening. So if you see in hemoglobin, so when hemoglobin, basically there is some porphyrin ring is here, where the iron center or hemine moiety is there. So when you are telling hemine moiety, there is +3 oxidation state, and plus when we will call him, basically him is present for hemine, and as well as +2 oxidation state also. In general we will call this thing. So in hemoglobin, basically this hemine moiety cofactor, and along with this some globular protein is there. So when the oxidation is happening, that time iron is going from +2 state to +3 state. That means one electron loss is there. So when it is reducing, or that time it is what is called on electron gain is there. When some in a lungs, when oxygen is coordinating with the metal center, it can oxidize the iron center to iron +2 to +3 state. And when it is going to the tissue body, that time oxygen is emitting, so that time it is again oxidizing. So there is some electron transfer reaction also happening. So in biological system also, or if you consider in photosynthesis also, photosynthesis of trees. So that time also what is happening, that some glucose formation is there. So basically CO2 plus H2 and it is forming glucose C6 H12O6. So in that case also there are some electron transfer or oxidation and reduction is happening. So these things is there. So and suppose now we are discussing more about the biological system. If you see in metallurgical or industrial scale also, suppose you want to extract some pure metal complex, metal complex from some ore, or some metal pure metal from metal complex. So that time electrochemistry you can do metal complex. So that time also you can do some electrochemistry, and you can do the reduction. Suppose some metal center is there in plus oxidation state, and you just do the electrochemistry, then it will form M naught. So which is basically going from ion center to pure metal formation, and it is nucleate, and you will get a pure metal. So basically if you want to do some electrophoresis or that kind of thing, then you also get pure metal. So that is basically you will extract the pure metal from some compound. So that things is there. And suppose you now what is happening if you put some metal in some solvent. So these things is suppose I took one iron or copper metal, and you dip in copper rod, and you dip in silver plus solution or silver nitrate solution. So what will happen? So basically if you see this thing, then you can see here that in this picture there is some copper center, copper rod is there. Okay, and then in this copper rod, and you will dip some silver nitrate is there. And if you dip for sometimes you will see that there's this copper nitrate solution, which is a colorless solution. So after some time it is become greenish, and this copper rod which is become some what is called silver color is forming. So what is happening basically here, that when the copper you dipped this some copper, it is metal state, so copper is plus 0 state, and it is going copper plus 2 state. So as a result, this solution of white or colorless solution become greenish color, and this silver color is forming basically Ag plus state is there in the solution. So a silver nitrate basically is Ag plus, and K silver nitrate minus. So this thing it is going to silver K not, so or zero state. So as a result it is forming some silver color solution. Okay, so in this case, so basically the here you can see this copper is going to copper 2 plus, that is when some oxidation reaction is going, and here some silver is going to silver not, that means reduction is going. Okay, so that means here also some electron transfer is happening, and that means some electrochemical reaction is happening. So electron transfer is happening as well as some chemical changes is happening. So that things is there. But now question is why copper is going to oxidation and why silver is going to reduction, why not the opposite reaction is not going. That means why copper silver is not going to reduction, and copper is not going to oxidation or something, sorry, reduction, this not going to reduction, and why silver is not going to oxidation, or what condition is required to go this condition, means which suppose you get two salt and one is suppose copper and other one is silver, and mix in some solution, then how you get to know that which sample is go to reduction, or which metal is going to reduction and which metal is going to oxidation. So these things we will get to know. So we'll discuss these things. So before this so we have some two redox couple, then now we can make a cell where we can measure the potential or reduction, where you can measure the reduction of this compound. So before going to this, we already know from school time that what is cathode and what is anode. So cathode, what is cathode and what is anode. Okay, so before that we will make a cell where you can see this is some I think in BSc time also we'll discuss this thing, or we'll learn in practical that when you want to do some potentiometric titration or volumetric titration, voltammetric titration, you used to do this kind of system where suppose two beaker is there and two beaker is connected with some U type of tube, so which is known as the salt bridge. So salt bridge, what is the function of this salt bridge? So basically here you take some solution, that is basically copper sulfate solution, which is and on the other hand you take some silver nitrate solution. Basically this one, now we are separated these two process in the two different one, and we will dipping two different metals. So in say copper sulfate solution you dip some copper rod, and in silver nitrate solution you dip silver rod. So what will happen? So basically here is copper rod, basically copper not is there, copper 0 is there, and in the copper sulfate solution copper 2 plus is there. So in this copper and copper sulfate solution there is some equilibrium is formed on the electrode surface. So as a result what will happen, that copper 0 or not, copper not is going to the electrolyte and it will form copper 2 plus, and on the same and same time this copper 2 plus also going to the rod and it will form copper not, and it will plate on the electrode surface. So there will form some equilibrium, and in the similar things also will happen in this container also. Silver is going to silver plus, and other thing is silver plus is going to silver, so there also some equilibrium will go on. So if you put connect with some voltammogram, and it will connect these two things with a salt bridge, where basically saturated KCl solution will there, or agar agar solution also is to put. So agar agar solution basically is to put, so to make the electric connection or ionical connection. So here you see that there some voltage is showing. So basically what is this voltage? So basically in difference of the reduction potential of these two electrode. Okay, so this thing is there. So now question is, what is cathode and what is anode? So basically cathode is where the reduction is happen, in which electrode the reduction is happen, that things is known as reduction is happen. So that electrode is known as cathode, and anode is where the oxidation is happen. So that electrode is known as happening. So that electrode is known as anode. Okay, so now we'll discuss earlier also that copper, I think in the first class. So if this reaction is happening, so then what you can say, how you can present this thing in what is called cell representation, so that you can get to know that which one is oxidation is happening and which one is reduction is happening. So basically you'll see copper is going to copper 2 plus, and other things there is Ag is going to Ag plus, or Ag plus is going to Ag. Okay, so this thing is happening, and if we will connect here, you can see that copper is going to oxidation. So here copper is going to copper, copper 2 plus is going to copper, and there is some salt bridge. So we will present salt bridge like double this thing. So and after that silver is going to reduction, so Ag plus is going to Ag. So this is the cell representation of this, where you can see that copper is given the copper 2 plus, this is the aqueous solution, and this is the solid, and this is also aqueous solution, and this is solid. Okay, so I think I can write a little bit more clearly. So copper 2 plus aqueous solution, so which is represent the phase where the copper 2 plus is there. So and copper is solid, then Ag plus, which is in aqueous solution, and then Ag is solid. So from here you can get to know that what is happening in this cell reaction. Okay, so these things is there, and then we now earlier I have asked that on question, what is the question? Question is, which metal will go to oxidation, which metal go to oxidation, and which metal will go to reduction. So how we will get to know of these things? So these things we can get to know from the electrochemical series, where this is the electrochemical series. So basically before that I want to discuss these things, that this is some electrochemical series, and where the hydrogen is as a 0, and it is called as a standard one. So I think we will discuss standard hydrogen electrode. Basically I think this one I have discussed in the first class. So what is how the standard hydrogen electrode is there? Basically this is a reference electrode of this, where the potential of this electrode is fixed, so we can measure other system with respect to this reference electrode. Okay, so this thing is there, and so here you can see that if this is all at the E naught value. So here in this series you can see whoever the more negative potential of the E naught value, and these all are the reduction potential. So E reduction potential, so basically E reduction potential means metal is metal plus is going to metal. Okay, so this thing is happening. So this E cell where you can see as the more negative potential it is reducing stronger reducing agent. So we have discussed that reducing agent means stronger reducing agent means it will reduce other component and itself oxidized. So that is the thing. So if you means if you take two component from this series and each one's potential is suppose okay, lead, you have taken lead, other one you have taken suppose magnesium. So here you can see that magnesium has a stronger reducing agent. That means it can reduce lead to lead 2 plus to lead. So if you take these two mixture of this salt and you will put in on solution, then you will see that lead 2 plus is going to lead, that is reduction is happening, and when the magnesium, that is magnesium 2 plus, will go to magnesium. So itself, oh sorry, I am telling okay, what it's called, it will reduce this thing and it will oxidize. So magnesium will go to the magnesium 2 plus. So these things will happen. So basically from here you get to know that initially where you have the copper, so copper is 0.34 volt, and other things we have Ag, so this is 0.8 volt, so 8 volt. So here you can see that means copper has a more reducing Q power, that means it can oxidize easily. So for this in the previous slide you can see that copper is more negative 0.4, for this it is going to the oxidation. That means the color of the solution become bluish, and when silver is going to reduction, for this silver Ag plus is going to Ag 0. As a result the silver color, what is called plating, is forming on the electrode surface. Okay, so this thing is there. Suppose you have get some chemical series of this different components. Suppose you have some H plus, where H plus is going to H2, and silver Ag plus to Ag, and then suppose cadmium 2 plus to cadmium, and suppose you have zinc 2 plus to zinc. Okay, so this suppose this four series is there, then you have to get to know, you have to know that which one will get oxidized and which one will get reduced if you mix these two salt. Okay, so these things you can get to know from this electrochemical series. You can get to know easily that H plus, what is this is 0, and Ag plus, this is what is called 0.8 volts, so more positive. That means the oxidizing power of H plus or H what is called Ag plus, is higher than the H plus. Then cadmium, if you see cadmium, where the here is the cadmium, and this zinc is here. So basically you get to know that which one will be reduced and which one will be oxidized. So here in this side you can see weaker oxidizing agent. So as it is stronger reducing agent, that means the weaker oxidizing agent, and this chlorine, which is a stronger oxidizing agent. Basically all the group 7 element like chlorine, fluorine, iodine, all are a stronger oxidizing agent, or like more electronegative atom, nitrogen, oxygen, all this all are fluorine, that are the more oxidizing agents. It can oxidize other material easily. Okay, so these things is they are now we get to know this thing, and Next is that in this scale we get to know if you okay, here is the application of this electrochemistry or how we can get to know. So basically in modern time what we are using this okay, now we are using laptop or what is called in mobile also. So that things there is some battery you are using, so battery which has some electrochemistry is going on, so basically the energy storage system. So energy storage system where some oxidation or reduction is happening. So if you see in our battery also, basically if you check in your battery, that is some lithium polymer battery. So lithium polymer battery, and in the lithium polymer battery basically lithium plus is there, so lithium plus in insertion and de-insertion is happening, insertion and de-insertion. Okay, so this insertion de-insertion happening where that means there is some electrochemical reaction is going on. As a result, you are what is called converting chemical energy to electrical energy, or electrical energy to chemical, transforming to chemical energy to electrical energy. So this thing is there now. There is two type of what is called cell is there. One is galvanic cell and other one is electrolytic cell. So what is galvanic cell and what is electrolytic cell? So basically when you are storing the energy, that means that is known as the electrochemical galvanic cell. And electrolytic cell, that is when you are taking the energy from the system, from the system, that is known as electrolytic energy. So basically there is two what we have discussed earlier, that if the reduction is happening, that is called cathode, and when oxidation is happening, that is known as the anode. So basically this process, that things is there, but it's better to call, or clearly you can say that the electrode where oxidation happen, that is anode. So basically if you suppose you have two cell, okay, so when here suppose oxidation happening, that is anode, and reduction happening, that is cathode. Okay, but when you will take some energy from the or from this system, suppose you connect your mobile from this system with this battery, then that time what is happening, it will taking the power from here and it is going. So as a result, whatever reaction is happening when during the charging or when you charge the battery, whatever reaction is happening in here, when you will discharge the battery, that time the different or opposite reaction will happen. Okay, so basically if during the what is called discharge, there is some reduction is happening, then here oxidation will happen. Okay, so and if you are discharging the battery, then during the discharging, if it is reduction is happening, then when you will do the charge, that time here it will be oxidation and here will be reduction. So basically the galvanic cell, whatever convention is there, when you will do electrolytic cell, that is the different opposite convention. Okay, so that things is there, sorry. And what is called battery example, a series of reversible cell. When an external charge generator change a battery, the cell electrolyte, when it is used operated headlight and the ratio or ignition, its cell is galvanic. Okay, so all these things whatever I have discussed, this thing, so this is there. And now we have now we will discuss that what we can do with this potentiometry or galvanostatic in electrochemistry. So basically you can get to know the total alkalinity of the seawater. Basically we get to know, I think in the previous also, how you can measure the hardness of water. So that things we have discussed, how we can extract from the ore sample or water to separate the metal complex of magnesium K2 plus and calcium 2 plus. So these things is there in the water. So from there we can get to know, means we can extract the magnesium and calcium sulfate sample. And now you can do potentiometry or electrochemically calculate how much calcium or magnesium is there in your sample. So from there you get to know the hardness or alkalinity of your seawater. Then that is called potentiometric titration. So and I will discuss this thing also. Means I think I did one experiment in ISC Bangalore. So that time okay, we record one video on potentiometric titration, some precipitation reactions. So that video I will show these things. So potentiometry method based on the measuring the potential of the electrode cell. So basically in electrochemical analytical method you can measure potential or voltage. Then you can measure current also. So basically potentiometric and coulometric. Coulometric means you are measuring current as a function of time, and potentiometric means you are measuring voltage at a function of time. So basically these two things is there. And also you can use this potentiometric titration to consumer product or clinical laboratory to determine the blood gases and industrial and manipulation of influence. So basically blood gases, basically how you can do if you do some electrochemistry, where I will discuss in next week also. That suppose you have in the iron center in the hemin moiety, and you have a hemoglobin. So in the hemoglobin is there in your red blood sample. And when you will do some electrochemistry, suppose you did some voltammogram, and if you only pure what is called sample, iron sample is there, then it will be cyclic voltammogram will be like this. So this is current and this is voltage. So it will be like this. If you are some oxygen or some gas, carbon monoxide or Cn minus, which is a coordinate, can easily coordinate with the iron center. So if it is coordinate, then this redox peak of the cyclic voltammogram become irreversible kind of thing. So this kind of thing will happen. So these things which known means from here you can get to know that okay, there is some gas which is coordinate with your metal or blood sample. Okay, so this information also you can get from potentiometer or electroanalytical method. Okay, so now we'll discuss about the what is called reference electrode. So basically we make that some what you can say, that cell where we have mentioned that copper to copper 2 plus, copper to copper 2 plus, and some salvage is there, then Ag plus to Ag is going. So how you can measure this things, the potential of this cell? So basically we can measure from Nernst equation. So basically Nernst equation is equal to E naught or E is basically observed potential, that is basically E naught, what is standard potential, by minus RT by NF ln product concentration by reactant concentration. Okay, so here what is called this R is the gas constant, T is the temperature, N is the number of mole of electron is participate in this redox process, and F is the Faraday constant. So each F is the value of 96485 coulomb per mole. So per mole how much charge is hot consuming in that system, so that is the value K of F. So basically you can get to know that K, suppose some oxidation or reduction is happening, then here you can get the measure the potential. So now I have mentioned here that this is the observed potential. So this potential is measuring with some reference electrode. So what is the reference electrode? Reference electrode basically the electrode potential where means some electrode which potential is not changed entire with the reaction or with the entire time of reaction or experiment. So that is there. So we already discussed about different type of reference electrode like silver or AgAgCl electrode, and this is saturated caramel electrode, and this is saturated caramel electrode. This is AgAgCl electrode. So basically in saturated caramel electrode, what you can see that here there is some what is called Vicor Vicor, what is called crystal is there, where it is permeable for selective ion, and there is some KCl solution is there, saturated KCl solution, and on this top calomel basically Ag2Cl2 is there, some crystal is there, and KCl crystal also there, and here some mercury is there, and this is the platinum electrode for the connection of this electrode. So these things, this is the reference electrode of standard calomel electrode, and this is the AgAgCl electrode. So basically there silver wire is there, where on the silver wire AgCl coated is there, for this it is glassy or black color, and on this saturated KCl solution is there. Okay, so this is the so I think there is some issue. Yeah. So these things is there. Suppose we'll do some potentiometric titration where you want to do some reaction where you want to means determine how the what is called suppose some precipitation reaction is happening. Suppose you have some what is called halide mixture, suppose Cl minus, bromine minus, and iodine minus, and you want to measure how much chlorine, bromine, and iodine is there in the solution. So that time we used to do some what is called in a what is called precipitation reaction or potentiometric titration, where you will measure the potential with adding some analyte, and this is your reference electrode, some AgAgCl or saturated caramel electrode, and it is connected with platinum wire. So where you can measure the potential difference of these two electrode when some chemical reaction is happening. So these things is there. So here I can show some experiment of potentiometer, where you can see that how we can use this potentiometric titration experiment to measure the reaction. So also we discussed that this potentiometric titration experiment is quite easy. So this experiment motive is to study, so you have some mixture of what is called halide mixture, three halide mixture, and you want to measure the solution. So in this you, for this you need some probe and some beaker, and in that beaker you add some 10 ml of mixture, and to increase the volume we have added 50 ml of water. And then you can then this is you can fix the beaker on here, and from pipette you add the silver nitrate solution. So basically silver nitrate, I think I have shown this one when I showed that how you can standardize some secondary standardized sample with the primary standardized solution. So basically silver nitrate, which we standardized by primary standard KCl solution with some indicator, phenolphthalein indicator. And along with this, where you can see here we already discussed that you can take some beaker and you put your what is called pipette, sorry, burette on the top, and you can add some silver nitrate solution. And here in the beaker you have it's called silver mixture of halide, and you can rotate with reaction when the reaction will happen. So basically here this is some probe which what is called to measure the potential. So to this is called, I think, some probe, I forgot this name, what is called OSB port or some port electrode is there. So and before this key measurement you have to wash the electrode. So basically here all the reference and working electrode whatever is there, that is connected with this thing. And after washing these things you have to connect with some connector. So this is the some remote controller electrode, Pasco OS PH wireless, so wireless electrode, where you have to connect. There is some software is there. So this is red line for power, and when it is Bluetooth connection, so you can connect with your laptop if you install the software. So that things is there. So yeah, so this is the software. So if you want to measure pH, then you can click on the pH sensor data configuration. So and here if you want to measure what is called voltage, then you have to add voltage. So as we want to do potentiometric, that means voltage you want to measure. So for this we have to add voltage. So and after that you have to give some name where to which sample you are adding. So here you can give the name, I think so here volume of because on the x-axis we will adding from the burette that silver nitrate solution. So for this it is written the silver nitrate solution, and username you can give your name or something. Then you can do what is called so this is there. Then you can add uh, volume. So how much volume we are giving in this potentiometric titration. So here you can put the your electrode here, and here and from the top of the things you can add the silver nitrate solution. And along with this, when the graph will come, I will show. Yeah, so these things is there. So basically here you can see when the silver nitrate is adding. So there is some whitish color precipitation is forming. Basically there is some three mixture of silver nitrate what is called halide solution is there. So as a result, silver nitrate, when you are adding AgCl or silver nitrate or sorry silver bromide or silver iodide, all experiment what is called happening. So means precipitating. So when the equilibrium point is reaching, there is shoot of the voltage, and you can see so all solution also become whitish basically because of the precipitation of silver halide. Okay, so this at the end I can see again here as the silver whatever mixture or halide is there, that is first okay, whatever what is called silver nitrate. Here you can see, I think I have to yeah, so this graph you can see there is some initially it is increased, then it will going linearly, after that it is increased, then again linearly it is going with the x-axis or parallel to the x-axis, again it is increasing. So basically here three halide mixture is there. So if you do some experiment also, you will see this kind of thing of halide mixture of potentiometric titration. So here, from here you will get the equivalent point of the mixture. So basically you know that ksp value, that solubility product constant. So whichever halide has a lower solubility constant ksp value, so we in that will precipitate easily. So here you can see, suppose this is in the sample we have iodine, chlorine and bromine, then initially it will precipitate bromine, silver iodine. So silver iodide precipitate. So as a result you can take from the equivalent point of this point. So for from there you get to know the volume, particularly how much volume is required for the iodine and how much volume is required for the chlorine and how much volume is required for the bromine. So the particular volume you will get, and from the volume you get to know the concentration of the chlorine atom, because you know the ksp value for particular system, silver iodide or silver chloride or silver uh, bromide. So this way you can measure the things. So I will give what is called this thing. I'll upload this video, this potentiometric titration with so for some precipitation reaction. So that things I'll add in Google Drive, all this video, and I will suggest this to the journal. So this is basically, it is a good for understanding the potentiometric titration. So these two journal or these two article also I will add in the what is called in Google Drive. So you can access these two journal also, and that video also I will add. And I think these things is there. Other things I want to other things I want to tell that this Nernst equation. So basically Nernst equation. So suppose you have A and B is going. I think I have discussed these things earlier also. C and D is forming, where the A molar of solvent and small b molar of solvent forming C and small d. Then what is will be the Nernst equation? E is equal to E naught. What is the standard potential? RT by NF ln. So concentration of product, concentration of what is called reactant divided by concentration of A and concentration of B, A and B. So basically initially this is the activity of the product. So for this one will be dash, so which is known as formal potential. So we'll discuss this formal potential more details later also when we will discuss cyclic voltammogram. So that time we will discuss more details of formal potential. So what is standard potential, what is formal potential, and what is the difference between formal potential and standard potential. So all these things I will discuss more details when we will discuss cyclic voltammetry. Okay, so now I think we can discuss some question from previous year. So we'll wait for 30 seconds or something, so if people can write on the chat box okay, that what is happening on the what is called question answer. Okay, so the question is, what happens when a piece of copper is immersed in a silver nitrate solution? Okay, so this is very easy question. I think In the past, we'll discuss on the picture with picture that on the beaker silver nitrate is there. So some copper or rod is going. So answer copper is oxidized and silver is reduced. Yeah. So this copper rod is there. Copper solution become green. So basically copper is going to copper 2 plus, and there is some silver point is there, so basically silver plus is going to silver. Okay, so this reaction is going on, so answer is B. Yeah. So next question is, there is some reaction is going, so which one, what is the order of oxidizing strength of elements present in the above reaction? So here I think you can see in this first reaction what is happening. So silver H plus is going to H2, so that is reduction, and cadmium is oxidation. So the order of oxidizing strength, so that means here H plus is going to reduction and it is oxidizing cadmium. So that means order of H plus is more greater than cadmium. Okay, so here you can get, and here what is happening, here Ag plus is going to Ag, that is reduction, and H2 is going to H plus, that is oxidation. So that means Ag is what is oxidizing this H2, so then oxidizing power of Ag plus is going greater than H plus. Okay, I think this is cadmium 2 plus, you can write. Okay. And here what is happening, so from here what you can say, so from here Ag plus greater than H plus greater than cadmium plus 2 plus. Okay, now here what is happening, here cadmium is going to cadmium 0, so that means this is reduction, and here this is going to oxidation, that means cadmium 2 plus is going to reduction, it is oxidizing zinc. So then that means here what is called cadmium 2 plus oxidation power is higher than zinc 2 plus. Okay, that means here will be cadmium 2 plus will be greater than zinc 2 plus. Okay, so what is the answer? I think C is the answer. Okay, so next question, what is the electrode potential for given reaction as per Nernst equation? Zinc 2 plus 2 electron is to zinc. So as we know, E naught E is equal to E naught minus 0.059 by N log of product concentration by reactant concentration. Okay, so here E naught minus 0.059 by N, what is N is 2, so 2 log of reactant, that is zinc concentration by zinc 2 plus concentration. So as zinc is solid state, so its activity is equal to 1, so that means E naught minus 0.059 by 2 log of 1 by zinc 2 plus concentration. So where is the minus zinc 2 plus? Yeah, so A is the answer. Next, what is the question? So fill the blank with suitable option given below. So zinc 2 plus visual zinc. So for the above reaction, electrode potential depend on what? The concentration of zinc, the concentration of zinc 2 plus, both the concentration of zinc and zinc 2 plus, none of these. So I think this is very easy question. Here you can see that it's depend on the potential of observed potential, that is depend on the concentration of zinc 2 plus only. So here this one also you can write this way, zinc E naught plus 0.059 by 2 log of zinc 2 plus. So it is depend on the concentration of zinc 2 plus only. So the concentration of zinc 2 plus only, answer B. So silver Ag plus 2S2O3 2 minus, it is forming AgS2O3. What type of reaction it is? So complexometric reaction, displacement reaction, decomposition reaction, none of these. So basically here you can see that Ag plus, so which is an S2 minus, the S2 as reacting together, it is forming Ag acid S2O3. So basically some complex formation reaction is happening. So complexometric reaction, you can say complexometric reaction is happening. So answer is A. So fill in the blank with suitable option given below. In redox titration, Fe2 plus is titrated against dash solution. Okay, so there is 3: permanganate solution, ammonium chloride solution, lithium aluminum hydride solution, KOH solution. I think if you watch Professor video, then I think, yeah, Ranveer has written A, that is correct. So KMNO4 solution, basically what is happened, KMNO4 permanganate, so MnO4 minus is there, so it will oxidize Fe2 plus to Fe3 plus. So this reaction used to happen. And so next question is, in which instrument pH is measured? Potentiometer, voltmeter, pH meter, coulometer. So I think it is very easy. So answer is pH meter, because it is on the name itself, it is there. So pH meter. So why indicator is used in neutralization reaction? It changes pH of the reaction medium. It detects the endpoint by changing the color of the solution. It acts as oxidizing agent. It acts as reducing agent. Yeah, so Ranveer has written, so this is answer is B, because usually we use some indicator which can change the color of the solution, so that we can get to know that okay, it is reach on the equivalent point or equilibrium where the end point is happening. So basically means A and B is reacting to form C, so A equimolar of A and equimolar of B reacting, and it is forming C. So that is that point it will change the color. So the answer is B. So which of the following in is an example of reversible cell? Lead acid battery, dry cell, Daniel cell, both A and C. So basically here you can say what is called reversible cell. So what is reversible cell? You can tell that a reversible cell basically which obeys the thermodynamic condition of reversibility. So that cell is known as reversible cell. So that means suppose some reaction is going on, A plus B is going to C plus D. So whatever forward reaction is going, that is backward reaction also going same time, and whatever reaction is going after the opposite reaction, it is completely returning to the initial state, that is reversible key reaction. So in this case lead acid battery, so which we use in earlier also, this lead acid battery and Daniel cell, what you which use in what is called battery in what is called in our day life. So that is all are what is called reversible cell. So D is the answer, both A and C is the reversible battery. So this is the answer. So I think this is the last question. Which one is used in saturated caramel electrode? KCl, potassium perchlorate, barium chloride, and NH4Cl. Okay, Ranvi has written last one also, D. So yeah, thank you, Ranvi. So this is the last question. So I think we have already discussed this thing. So what we can use in saturated caramel electrode, where we see that see platinum wire is there, there is some mercury, and after that mercury Ag2Cl2 caramel is there, then KCl crystal. So this one is on the saturated caramel KCl solution. Okay, so then some Vicor feed is there. So on this all the setup is here like this. Okay, so these things is saturated caramel electrode. So in these things the answer is A. Okay, saturated caramel electrode KCl is usually used for to maintain the KCl solution. So I think we have discussed 10 question, and also I think time also is over. So if you people have any doubt, then you people can ask the question here. And I will upload this slide also, as well as whatever this that two articles. I think that two articles is quite good, so you people can read these two articles, and and you will get some more information about the potentiometric titration and how you can use this electroanalytical method to get to know how much silver or some halide is there, how much concentration. So and that video whatever I have shown, that Dr. Achinta Jana also there, lab instructor in UG key course. So he also helps a lot to make that video. So I also share that video also, so you people can watch how can perform the experiment using this analytical method, and you can calculate the amount of how much light is there. Okay, so if you people have some question, you can ask. Okay, I think no one have any questions. So okay, thank you very much for joining. uh, okay, then we will meet next week on